Hello guys, I thought today I'd show you how I'm implementing a part of the associative array literal thing for NewCTV, and it turns out that I will have to pull out the backend stuff that I did for array literals into the front end in order to do that properly. And right now I want to write a proper version of a thing that evaluates the hashes, because right now we have a CTF interpretation for every single key we want to hash, and that is of course wasteful, and what we'd rather want to do is to pass an array of keys, like that, log who cares, maybe like scope log, scope ref log equals log dot mf who cares. We have that log, I guess, log comma, and what does it want after that? And there we have a type and an element expressions, which luckily we all have. So the type is the key type dot array of and the expressions is the keys. So this gives us an array literal for all the keys that come in. We then want to construct a function that takes that and basically does a for each loop over that key array and calls the hash function on that. So the way we can factor out this logic that constructs the call is a bit involved, because how the call is being done, whether it's being done on a 2-hash function that we got from the struct or on the template instance of hash of, are two different ways of doing the call. So what we have to do is we have to pass in this key expression, and that key expression can be an index here. So now we pull out the thing that constructs the call. That's that here. That we can pull out, and we can make a thing that is static call expression. Oh yeah, call exp make hash function call, and that thing takes scope expression, which is the key exp, and it also takes the type key type, which is also scope, and that's it. Yeah, that's it. So then we copy paste the stuff here in, and instead of calling this call, we replace the key with key exp. This we just replaced key with key exp. Every time we have this expression key, and let's make it a bit easier on us. Let's just say scope expression key, and now we have created a variable that this can reference, and now we rename that to key exp, and everything should be good. Now, okay, now we have renamed it to key exp, and we've got everything we need to construct the call. Now, this stuff is all completely dependent on the key exp. That's fine. I do not have an issue with that at all. Everything is constructed locally that we need, so we can just return the call. Return call. So now we have the whole selection of the how we want to call the hash expression is now factored out. So what we can do is remove that stuff from here. That. And instead we just have call. So let's go call equals what did we call this function? Make hash function call. Make hash function call. The key exp is the key, and the key type is the key type. And now we have that factored out. That's nice. I like it. And now we have the actual call. Okay. Now, if we want to do multiple key hashes at once, right? We want to do this evil hashes thing. What we do is we create a function literal that we then just call. So we just say func equals new func x. And the func x is a function literal. Takes the location first, I believe, and then it takes func x has to take a function literal declaration. Okay. I mean, we can do that. We can just paste a function literal in here. It's not so bad. There's a scope. Scope flit equals new func literal function literal. Okay, what do I have to import to get this? I guess import dmd-func. That could be a place where a function literal is defined, and it's possible that it's called func literal. Yeah, a func literal declaration. It's a func declaration, but who cares? Now we can go to where that is defined, and we can get that. Okay. So I guess we want the token to be top. Let me have another look at the constructor. The constructor takes two locations, start location and the end location, which in this case is both the same location. It takes a type, which I believe is the return type. Let me see at this constructor. No, the type is the type of the function. The type is the type of the function. It's not It's not the return type. So we have to construct the type of the function ourselves. The type of the function that we have here is actually quite simple. It's a function that takes a key, an array of keys, and it returns an array of hashes. So that's quite easy to do. Let me see, where was I? There's already too much code for my liking, but I mean, at some point you just have to do what you have to do. Alright, that's where we are. So now let's create the type of the function first. Let's say scope ftype equals new type function. And of course I don't get the let me try and restart my monodevelop and see if I can get auto-completion for the constructor call, because that would be awesome. Because usually that works. Okay, that's no longer needed. Okay, now. Do I get auto-completion on this now? No, still not. But at least I can go to the declaration. So I can look at the constructor. The constructor looks like this. Don't know why arguments are in the type function, but well. It looks like that. So there is a parameter list, which I guess I will have to fill out. So let's have a scope of PL equals parameter list. That at least gives me a CTOR. It takes a parameter star, thing, and storage classes. So I have to make parameters. Scope parameters equals new parameters of 1. And for that I have to import the thing that does that has all the array types. Import indeed.array types. There we go. That gives me the parameters type. As you can see, now I have it. And now I can do, I have 1 parameters, and that parameters will also be filled with a actual parameter. We just say scope parameter equals new parameter. And now let me look at what the constructor for this says. It says this. That's fine. I can create that one. It takes a storage class. Which storage class default, who cares? Now the storage class parameter. I think that is a correct storage class. I will have to see where that's defined to import it. The type of the parameter is it's a key type. That's not quite true. The type of the parameter is in keys type, because that's the array, right? Like the in keys is the argument for this parameter. Then we have an identifier which we call ID pool. Identifier.ID pool. Guess we gotta import DMD identifier as well. Here, file like that, and then we should be good to go. ID pool is in keys. And then we have the expression, which is default argument, that's null. And we also don't have the user attribute declaration, it's also null, so that's our parameter. So now we fill in the parameter into our parameters, into this array. So we say parameters of 0 equals parameter. We put that into the parameter list, parameters. And let's see if the parameter list needs anything more. It wants the parameters. It wants a storage class. So storage class of ... Oh, var args and storage class are already taken care of. So yeah, that's all we need. So now in the type function, we have the parameter list. That comes first, parameter list. The return type is an array of hashes. So that is type.hash t, I think t-hash t, dot array of. That's what it is. Technically it's const, but who cares? It's an auto-generated function, so nobody cares. We could say const keys, or we could even say in keys, but it really doesn't matter, since at least the DMD optimizer does not care. Linkage. We need a linkage. No, actually we don't. Default. We can go with default linkage. If we so choose, that's actually fine. Linkage should be in import DMD declaration, comma link. Yeah, it's in declaration. Link. Alright, now let's see. I mean, we just imported links, so I don't know why we don't get it. Perhaps I gotta restart MongoDB again. Link init, who cares? And the storage class we don't need. So now we have the function type. So we can start on our function literal declaration. But I think I'll just do a function declaration. Yeah, I will just do a function declaration. So that's easy. Scope fdecl equals new function declaration. Of course, we don't get completion for the constructor. So let me just put the constructor in here. That is this. So the location is the location. The end location is the same location. The identifier is, I don't care, identifier. There is a way to make a unique ID, right? Generate anonymous ID. ID. Hasher. Identifier. Now comes storage class. Storage class should be storage class static. The type is the function type we have just created, and it's not a no return function. I can't help but notice that we do not put the body in there. So let's put a body in there. Scope f body equals new compound. Compound statement, and I think for the compound statement we have to import DMD statement. Import DMD statement. That's fine. All good. New compound statement. The compound statement is the function body. Let's see what it takes. It takes... Oh, that's the compiled statement, not the compound statement. We want the compound statement, not the compiled statement. Compound literal expression. Compound statement. That's what we want. Have a look at the constructor. Don't know why this is final. And the other ones aren't, I guess. Some premature optimization. Or not really finished optimization going on. Who cares? We now can build up our statements there. The log is the location we got, and the statements is the statements, which means now we have to have the statements ready, and that now is the actual function body. F body statements equals new statements, and let's see how many we need. So there shouldn't be too many. What we do is actually now we have to create a variable declaration from this, because otherwise we wouldn't know. But I think we can have semantic just take care of that. So let me just start. So the statements we want look like push statements, push something up there. The statement we want looks like let's write out what we want. So we have a function that goes like hash t-array hasher, and it takes keys array keys, or like in keys, call it. Yeah. All right. And what it now does, this is the compound literal that we are writing now, is for and or whatever size t key idx equals 0, key idx less than length keys length. Maybe we also have like const. We don't have. Let's do a length expression. Let's do like that. And keys length. And then we have that thing now has alright, we also have a variable declaration for the result. Hash t array result equals u hash t array of n keys dot length, and then we in here we just do result of kidx equals hash of key, and we see, wow, that will be the hash function call. Like we have this nice hash function call. That will be the hash function call of keys of kidx, and that's an index expression which we can pass as the key expression to the make hash function call, right? So now we will have a little bit of trouble with doing the declaration statement here. I believe that thing here is declaration statement. I haven't written one of these before, but we will see how to do that and if it works. And like that we've already taken care of. Now we have to do this. And I think the first thing we want is a declaration statement. So let's see, do we have one declaration statement? I have a compound declaration statement. I don't want a compound declaration statement. I would like to have a regular declaration statement. I mean, I could also do a declaration expression, I believe. And put that into an expression statement. That's possible. Let me see what a function like this would look like in the AST. And I can luckily do that because I have called a reflect. Hasher. Let me just copy what I just wrote here. That. Technically that's a static function, like nobody can actually call it. But let's Let's make it static private because who cares. Let's first see if, let's say alias key equals string for now. And then we can see what this will compile to. And if it compiles at all, I believe it should. We forgot the k-alias plus here. And we forgot the semicolon here. And we have to have a hash t hash function call takes key and is left undefined. Can't use operator on expression of type void. Why would result be an expression of type void? So for some reason it seems that result is not a new hash t. What do you think result is? Lemma message type of result. And of course we have to return result here. It says results the u-long array because hash t becomes u-long, so that should be fine. Yet oh, it's just because this has to be in keys, right? Yes, okay, now it makes sense. I don't like to have the return type inference here. Let's just say hash like that. That works. Now let's see what DB makes out of that. It would rewrite the for loop to look something like this, which is completely fine with me, but I need to see what the tree will look like, and for that I can use CoreReflect. Luckily, so I can do now mv hasher .d.cg goes to hasher.d. So now we have the hasher.d. We have this nice lowered form that will not change, and therefore we can easily use to run our thingy that shows us the AST. So what we do is we import the thingy that shows the AST. Just say import CoreReflect, and then we have a little function literal here, which we frame a message out, and we do that. So first, to get the print out of the tree, because it can be recursive, we need to give it a associative array, a hash map, which has a string and a ulong, and the ulong has to be immutable. Immutable ulong as a key, and that is our CMap, whatever. And then we say result, and we just return I think it's called node to string of the node and the address of the CMap and I have here auto node equals node from name, and now the name of the function hasher, and that will give me the information that I need to have about the IST to then be able to, and that's wrong, I have to go like this. This will now give me the information that I need to have about the IST to create the same thing. So all I have to do is run that with my DMD hasher, and now I see all the function declaration stuff. So I see that the return type is a slice of t's. I have parameter types, and in parameter types I also have the identifier. I have the parameters, which are that, and I'm not sure how easy it is to get that into the thing, and I also don't get the function body, which surprises me. Oh, I think the default for get node from name is that you don't get function bodies. You have to give it a special special reflect flag everything, and then you get the function body. Does it reflect flags everything? Yes, now we get the function body. Okay. Okay, the function body starts with a compound statement, which we call a block statement. So that block statement has statements in it. First, it has an expression statement, and in that there is declaration statement. Yeah, that's what I would have expected. That's what we are going to have to build. That's just how it has to be, I guess. So we have a declaration, an expression statement, and in that there is declaration expression. That's fine. We just say I don't care, auto scope S1, because we are going to have a bunch of these. So in that there is no, we have to do the other way around. We first have to do the decl statement. We first have to do the declaration expression, put the variable declaration in there, and then we have the construct expression. Yeah, you know, I feel like this is the tree that we would have to build, right? I feel like I understand now why people don't do this. I feel like I understand now why you just use the string way of doing things. Well, yeah. Can't really pause the recording, so let's move on. So, creating this stuff here was fun, but it ain't gonna work. Let's go into a place where the same thing is being done, which is the place that hashes. And I forgot where exactly that happened. I think it's in destruct, where I guess it gets the hash function, hash, x hash. Yeah, it's like a 2x hash, 2x hash. That is the place where we need to look for how to do this. 2x hash. Okay, let's just look for x hash for now. And then we should see that the 2x hash somewhere. Build 2x hash. Where are you? Build 2x hash should be in destruct D, according to these outdated things. Or in clone. I almost believe that it's in. Yeah, it's in clone. It's in clone.d. Okay, let's go into clone.d and see what's going on here. Build 2x hash. Yeah, you see that? That's what people do to try and avoid having to do all of this themselves. I mean, that's fine. To me, that's completely fine. I can live with doing that. We are going to copy exactly what they did. Yeah, we just copy this stuff. They put it in something they call fop. Fop is the function what? Fop is what? Where is fop defined? Fop is a function declaration. I guess fop stands for function operator because it's an op hash. Who cares? We can just use the same method of building it because this ain't gonna work out. So let's put that into a comment and paste the fop building code into there. Alright, and then we just change. We can use the nice Q literal for that. Then we just change what's being done. So what is being done is that we have hashes, which I guess we can just do this array hashes, and then we just go and look at the cat hasher hasher d. That's here cat hasher d. So the thing has a little bit less to worry about. We run a deformat about it. Do I have to picked up run different t hash d? Right. We could just use that. This is our function body, and a few things will have to be changed in there, especially especially the call. So that means we can't actually do it like that, because we need to put the call into the generated code. We need to exchange the call expression in there. Yeah. Yeah, that's not what we want to do, is it? Because we cannot exchange the call. Well, okay. That then means we are going to have to go down the painful route and just write the body ourselves. What a pain. What a pain. Well, there is one more thing that we could do. We could have an import in there. We could import object and use the hash of function if there is no toHash. And that would work. So we simply write the code that we would write. And like do not have the call resolution at all. We just put an import into there like that. We just import core dot internal dot hash. Then we say static if type of keys of 0 equals struct actually we don't have to do that. All we have to do is to say for each key in, or I guess we could copy the code from Hasher just to be a bit better about this. Like that. We can just copy that code, and instead of hash function call we say hash of like that, and that's that. I believe hash of will that hash of will I'm not sure if I can get to core hash internal hash. No, it doesn't look like it can go there, but I believe that will call the correct two-hash function, if I'm not completely mistaken. So that is what we could use as the code. The compile statement is a mixin, and basically we just have a mixin. So yeah. So the function body is just a mixin. There we can do parameters 1. We don't have to push it. We can just do 0 equals like that. Ref const sd.type is not a thing. This is key type. IDP is also not really a thing. We want that to be this key type array of even the ID is identifier dot ID pool in keys. The rest is null, just like in our thing. We make a new type function which is no throw and trusted. We say ID equals ID to hash. That's not what I want. I want identifier.anonymous ID and hasher. Function declaration is declog. Both are log.initial actually, but who cares? TF is type function, this is static, it's generated, that's true. This code should be correct. And it should call the right thing. And now we don't even have to like do the import thingy. So this is all way less code than this would be. And after that, we have the function body. So all we now need to do is to actually do the evaluation of that. So all we have now is a call expression that we create. So we have scope call, and now we do call equals new call expression, and we just call log, who cares, that one is not one, so that log is not here anymore. Log and it calls. There are many ways to call expressions, all beginning with log. I think we want arc because we just have one argument for that. So we have to make this function body into an expression. Is that true? I thought we could call on declaration. Yeah, this is the one we want. Where we have a function declaration. Yes, it'll create a var expression inside to make it an expression, but who cares? That's the one we want. We have the function declaration, that's called fab. I want to rename that fab to hasher. Okay. Hasher. And the argument that we're going to pass is our in arcs. So now we are going to call hasher with the keys we just passed in, and this is now no longer needed. We have this call. We evaluate this call. And we funnel the result out. So what we do is we say call.secretlyinterpret, and that will lead to an array literal expression. Interpreting this call will lead to an array literal expression, and we then return the ALE elements. Ali, and just do that, and then so is array literal expression. We assert that Ali is there. And then we will return the elements of that. And these are elements. This will not be array, literal expression. And then we return elements. And if you look at elements, that's an expression star. The issue with this now is that those are not pre-allocated, which is not really what I want. Because I want to be able to delete those. So what I actually want is for that to result in an array of ulongs. So the scope out ulong array. Right? So now I can go evaluate the elements, and then they could be freed, right? So I can do this for each, and we assert that we have the for each breadth hash and key hash and hash results and hash results. I want the index here as well. We want to make sure that the hash result equals the ale.elements, and I think that is, yeah, that's a pointer, so we have to do this. Ale elements I dot to there was a thing like 2u integer. I think it's here somewhere. And the thing that builds it. Yeah, hash results 2u integer. That is what we want. This will give us the ulong. And while we are at it, we may as well call a hash finalize on that, or finalize. Oh, it's a hash finalize. So, yeah, I think that's what we actually want to do. So we say auto hash equals that. Then we say hash result equals the hash finalize of that hash. And then we can free the results the CTF would have created. Make that a scope, and we would hope that that would get cleaned up. Of course it won't, but it could be, and that is what we want. And after we did that, we return the hash results. No, we don't return anything because that's an outref. Yeah, it's a scope out, scope left out, and that should evaluate the hashes. And yeah, right. We have to check one eventuality, which is that the CTF evaluation of the hash function may fail, and in that case we will have to do something better. And that should be size t because we can't assume that we are on a for the bit thing, hash t, it has to be hash t, cannot be u long, since, right, okay, I'm happy with this. The debugging we are going to do in the next episode, I believe. Alright, take care.